All right, so in this video, we're reviewing how to find the oxidation states of different elements in a reaction. So in this case, there are three major rules that we have to follow, or really they're guidelines for us. The first is that if the charge is given to us in the equation, then you should use that charge as the oxidation state. The second rule is that if an element is completely by itself, then the charge is going to be 0. And finally, if an element is in a compound, then the total charge of that compound must be 0, and we can use one of those charts to figure out each individual oxidation state. In this video, I'm going to give you an example of all three different rules in effect. So in this first example, we're using rule 1. If the charge is given, use that value. So you'll know if an oxidation state is given to you because you'll see either a plus or a minus along with a number in this superscript region. All right? So in this case, this Ag, or silver, has a charge of plus, and we know that this charge is plus 1. Remember that if a number is not written, you can assume that that number is going to be 1. So here we know that Ag, silver, is plus 1. Now sometimes people confuse this with the rule that says that if an atom is by itself, it has a charge of 0. In this case, our copper would have a charge of 0 because it's by itself and no charge is indicated. While silver is by itself, a charge is indicated, so its oxidation state is going to be plus 1. Over here, copper has a charge of plus 1. I know because it's given to me. And my silver is now by itself without anything given, so this must be a charge of 0. In this next example, we're looking at the decomposition of water. Water breaks down into hydrogen gas and oxygen gas, okay? So when we're looking at this, there's a couple things I want to tell us right off the bat. So coefficients often confuse people. However, in this type of problem where you're looking for oxidation states, you can totally ignore these coefficients. So I'm just going to cross them right out so that we don't worry about them when we're working on this problem. So when we look at this, we're ignoring the coefficients. We have two different things going on. I have two elements that are totally by themselves, my hydrogen and my oxygen. Even though there's two hydrogens and two oxygens, because the element itself is alone, only hydrogens or only oxygens, then I know that my oxidation states are going to be 0 for both. 0 for both my hydrogen by itself and oxygen by itself. That leaves me with the hydrogen and the oxygen in the water compound. I'm going to need to use a chart to figure out the oxidation state of the hydrogen and to figure out the oxidation state of the hydrogen and of the oxygen. I don't do an oxidation state for the whole compound. I do an oxidation state for each atom in the compound. And to do that, I'm going to use a chart. Here I've just set up a chart that I'm going to use to figure out the oxidation states of hydrogen and oxygen in my water compound. Now overall, because this is a compound, I know that the sum of the oxidation states must equal 0. So I can write that in to start. I also know that I'm looking at hydrogen and oxygen. So I'm going to write H and O into my chart. The next step is to write down the subscript. The subscript is the small number that comes after the element symbol. So here my subscript for hydrogen is 2. The subscript for oxygen is going to be 1. The next step is to look at the oxidation states from the periodic table. So if I'm looking at my periodic table and I look at oxygen, I can see that there's a small 2 in the upper corner. Now that 2 tells me the oxidation state of oxygen is 2. Over here on the other side, I have hydrogen. Hydrogen could either be +1 or it could be -1. So we use our chart to figure out which oxidation state we currently have for our hydrogen. So what I'll do is I'll write in the -2 for my oxygen. When I go down the columns, I multiply. So this is going to be 1 times -2 to give me -2 on the bottom. So the next step is to look across my row. I know that this number plus this number must be 0. So I need to put in a number here that when added with -2 will give me 0. In this case, 2 will work nicely. 2 minus 2 equals 0. So then I can go ahead and fill in this square here, my only remaining square. This is going to have to be +1. I know that because 2 times +1 is going to give me the 2 that I need to balance out with my oxygen. So ultimately what this is telling me is that the oxidation state of hydrogen is +1, and the oxidation state of oxygen is going to be -2. These are from this row right here in our table.